This is an AS Mechanics question on connected particles. Two small balls, P and Q, have masses 2m and km respectively, where k is less than 2. The balls are attached to the ends of a string that pass freely over a pulley. The system is held at rest with the string taut and the hanging parts of the string vertical as shown in figure 1. The system is released from rest, and in the subsequent motion, P moves downwards with an acceleration of magnitude 5g/7. The balls are modelled as particles moving freely. The string is modelled as being light and inextensible. The pulley is modelled as being smooth and small, or small and smooth. Part A, using the model, find in terms of M and G the tension in the string. Okay, so the first thing I need to do is to put all of the forces on this diagram. So I'm going to start with the weights. So the weight of P is 2mg and the weight of Q is kmg. Because it's attached to taut string, that string that's sort of stretched and not floppy, we're going to have tension. The tension always pulls away from a particle. So we'll have T going up. Now, the reason I can mark both of these with the same tension is because the string is modelled as being light, which means we're ignoring its mass and assuming it's got a constant mass throughout its length, which means that the tension is going to be constant throughout it. And we're told that once it's released from rest, P moves downwards with an acceleration of magnitude 5g/7. So let's put that in. P moving downwards, or accelerating downwards, 5g/7. That means that Q is going to be moving upwards with the same acceleration. And the reason I can use the same acceleration is because we're told that it's being modelled as inextensible. Now what that means is that it's not elastic, it's not stretching in any way, and both particles are going to move with exactly the same speed and accelerations, even if it's in the opposite directions. Now, to find the tension in the string, I need to write an equation of motion either for P or Q. Now, if I use Q to write my equation of motion, I'm going to have K in my working, and K is unknown. So it makes more sense to use particle P and write an equation of motion for particle P. I'm taking downwards as positive, and I start by looking at resultant forces. 2mg going down minus the tension which goes up is equal to ma. M is 2m and A is 5g/7. Let's rearrange this to make T the subject. So I'll have T is equal to 2mg minus, now if I multiply this 5g/7 by 2m, I can write that as 10mg/7. So the last thing I need to do is to work out what 2mg minus 10mg/7 is, and that leaves me with 4/7 mg. So there's my tension in the string. Part B. Explain why the acceleration of Q also has magnitude 5g/7. Now, I did just speak about that, and the reason why they both have the same acceleration is because the string has been modelled as being inextensible. So we can just write that down. So because it's inextensible, it means that P and Q move at the same speed. Part C. It's asking us to find the value of K. So to do that, we are going to need an equation of motion for Q. So let me put the forces back on again. So we have 2mg as weight of P, weight of Q, kmg. We have the tension now, which we calculated, and that tension is 4/7 mg for both. So 4/7 mg. And I'll put on the acceleration. So for P it's 5/7 g, and also for Q it's 5/7 g. Now I can find K by writing an equation of motion for Q, because the only unknown in that equation is going to be K. So an equation of motion for Q, I'm taking upwards as positive since it's moving in that direction. So the equation of motion is going to be T, which is 4/7 mg, pulling Q upwards. What's trying to stop it from going upwards? Its own weight, which is kmg. So there is my resultant force, and that's equal to ma. We're using F equals ma. So the mass is km times the acceleration, which is 5g/7. Now, what I can do at this point is I can do some cancelling down. Every term has got m in it, so I can take out m, and every term has got g in it, so I can cancel out the g's as well. So at this point, what I have as an equation is 4/7 minus k is equal to k times 5/7, or 5/7k. Rearrange to make k the subject. So if I add k to both sides, I'll end up with 12/7k is equal to 4/7. If I divide both sides by 4/7, I will get k is equal to 1/3. Now, normally when you have questions where you're using g, you shouldn't give an exact value of k. It should be rounded to, or an exact value as an answer, because g has been given to 2 significant figures, so we should really give an answer to 2 or 3 significant figures. However, notice that g got cancelled out all the way through, so it doesn't matter what value of g we used, we are still going to get 1/3. G has no impact on the answer, so here we can give an exact answer. So if that ever happens, you've got G in your working and it cancels out, you can give an exact answer. And then lastly, we look at part D, and part D says identify one limitation of the model that will affect the accuracy of your answer in part A. Now we need to be careful. You should not say having the mass, including the mass, to get a more accurate answer, because that won't make any difference. All the mass is cancelled out, so the mass won't make any difference to our answer or the accuracy of our answer. Neither will using a different value for g, using a more accurate value for g. That will make no difference to our answer because all of the g's cancelled out. So it's not got to do with the mass or gravity, it's got to do with the simplifications that were given earlier. And in the beginning of the question, it talked about the string as being modelled as light and inextensible. So this is what we're going to base our limitations on, the information that was given earlier on. So our first limitation is that the tension may not be constant throughout the string. We assumed it was, which meant that when we worked out the tension on the P side of the string, we used that in our equation over here for the Q side of the string. If it's not constant, if it's not modelled as light, then we would have a different tension on the Q side, a different tension in our equation. We'd get a different value of K. And the second limitation is that the acceleration of P and Q may not be the same. We use the acceleration for P and use that for the acceleration of Q. So there's the acceleration there. If the string was stretchy in some way and it wasn't inextensible, then we would have a slightly different value for the acceleration here and a different value for K. Now, both of these limitations are based on the light and inextensible part of the simplifications that were given earlier on in the question.